Hey guys, so today on the 28th, we are going to be picking up in the lesson number 29 here in our series on picking up programming in a practical sense. And today we're going to be talking about version control in terms of a conceptual introduction. So we're not actually going to practice things with it specifically relating to Git. That is the version control software that we installed at the end of our last meeting. But before we even get into doing things in a hands-on sense, we're going to talk about it conceptually. And that's because this is one of the trickier aspects of learning how to be a software developer, especially integrate onto teams where you have to make your changes to a code base alongside many other people. This is a very important skill that often doesn't get emphasized enough in the college environment, at least in my opinion. I didn't learn almost anything about it in college, even though it is something that comes into play every single day when you are working on an actual team. And so we're going to spend a good bit of time just hitting this idea of version control conceptually. And specifically, as we'll see here, I'm going to be using an analogy to talk about things here. So this is the outline of the things that we're going to talk about today. So we're going to start out just kind of talking about the fact that version control can be tricky to understand, and it usually does actually take people a while. It's not something that you'll probably just instantly be able to snap your fingers and rattle off what everything means and how everything's related. You'll see what I mean in a second here. There's just a lot to kind of wrap your head around. And so you shouldn't get discouraged if it takes you a little bit. Eventually, hopefully things will click and you'll start being able to see how everything relates, but it may take a little while. Because what seems easy for people who've been doing this for a long time, maybe it's not so intuitive the first few times you see it. And so you just shouldn't get discouraged on that account. Then we're going to talk about an analogy that will help us hopefully understand some of what we mean by tracking changes. So we're going to use an analogy relating to the ledger that a business might have. So a list record of transactions used to represent business finances, that's going to be kind of the analogous situation that we use here to understanding changes to our code with version control. So now we're going to talk about all of these terms involved in version control. So repositories, commits, pushing, pulling, those are kind of like the basics. Then we're going to talk about branches, and then work items, tasks, product backlog items, abbreviated as PBIs. These are all synonyms. Kind of depends what sort of a task management system your software development team might use. If you're in the Agile framework, PBIs is what my team calls them, but yeah, I've seen work items and tasks too. These are the goals, the chunks of functionality you're trying to implement. Then we're going to talk about merging. You merge branches, and we'll get what that means in a second. Pull requests, and finally we'll go over some other stuff like diffs and cloning and ignoring things that you don't want to track in version control. Even when we get there, we're going to note that we've made some simplifying assumptions for this first pass. We're not even going to hit everything completely as it is in reality our very first time looking at it, just because there's so much. And after all of this, we're going to move from the analogy. I don't actually have so much written here. We're just going to go look at it. So I have, this is the Git repository for the ministry website that I've been working on. So you can see I'm here on GitHub, which is this remote repository host. We're going to look at one of the pull requests that I made in this repository. And that should hopefully help us understand the difference between repositories and pull requests and branches and commits, because all of those things I just said are very easy to confuse, especially when you're first getting introduced to these topics. So that probably doesn't mean too much to you now, but we'll get to it as we go there later on today. So first thing, as I was saying, just as a foreword for us here, version control can be a hard topic to understand or wrap your head around, and that's okay. You should give yourself some slack here. Just be prepared for this to take a little bit of time for you to be able to wrap your head around. Most people don't get it the very first time. So ask questions if you get stuck. If you don't understand what the purpose of something is or what the differences between some of these terms are as we're going over them, please do ask questions, because it is pretty tricky to get these things straight in your head. Once you do, usually it's like a one-time thing. Once you have your aha moment, your eureka moment, you'll kind of have it after that. But getting there can sometimes take a little while is what I'm saying. So And like I was saying just before, a lot of new developers have problems distinguishing between these things here. So repositories, branches, pull requests, and commits. All of these things are sort of related, but these things all represent, sets of changes or, the state of your project at a given point in time. And so given that, sometimes they seem really similar in the minds of new developers. And so it can be kind of hard to tell them apart and what the differences are, what they're used for, how we talk about them. So just as we go through all of the terms, I haven't done them exactly in this order, but as you go through, you just may want to pay some special attention to these things specifically, because these are often the terms that people stumble over because they get them confused with one another. All right, so with that out of the way, we're going to try to use an analogy. So in fact, you might be a little bit put off. We aren't going to talk about programming. We're not going to talk about code for like the next 10 slides or something. Everything that I'm going to bring up today in our high-level conceptual overview of version control is going to be through analogy. And that's just because we're talking about the concepts here, not the specific concrete implementation used by Git, our version control system here, but we're talking about what each of these concepts represents. Like, what is it basically doing? How does it relate to some situation that we might have more of an intuitive feel for that's not just lines of code? So the analogy, the lens that we're going to view all of these things through is kind of a business analogy. So let's say this. Let's say that you run a business alongside several business partners, with each of you having a local ledger where you keep track of your business's finances, with a master copy of your business's overall accounts kept in a secure bank. So just to repeat this, might seem repetitious, but we just want to make sure we're being clear. You, alongside several co-owners of your business, each have a local ledger where you're keeping track of your business finances, and then there's a master copy of your business's overall accounts kept at a bank. And so the one at the bank is separate from the one that all of the individuals have. And the bank's copy is quote unquote the real one. So under law, this would be the one that if you got audited, in terms of taxes or whatever, the one at the bank is the one that would be referenced as the authentic current version of the record. So it's kind of the one that is considered the last stop. This is what the current state of the finances are, set in stone. This is the original copy, if you will, that everyone else has to work off of. So this situation that we're talking about here, where individual co-owners in a business might each have their own ledger where they keep track of the financial transactions that they specifically make, and then all of that ends up eventually flowing into a master copy of your business's accounts that are kept in a secure bank. This situation is actually quite parallel to how version control will work in code. So specifically, the sets of changes that we're tracking, that's the versioning that we use in version control, very similar to this idea of having a ledger, something that tracks transactions, individual things that change the state of our code base. Very similar, very parallel here. That's why we're going to try to use this business example as an analogy. So we're going to try to define all of the terms here based off of this analogy that we're setting up. So before we go ahead and move any further, does the general situation that we're bringing up, does this make sense at a high level?
Yes, it makes sense. It makes sense.
Okay, cool. So now we're going to do kind of the easy stuff. So most people can kind of get this the first try. These things aren't usually where people get hung up, because as long as we keep it set to just these things, it's not so bad. So we said that each individual here has a ledger, right? And then there's one that's shared between everyone that ends up at the bank, and that one represents kind of like the final copy, right? So in our terminology, each ledger, each record of the business financial transactions is going to be called a repository. That is the word used of them in programming terms. So in our analogy, we're just going to call these records, we're going to call them repositories. So each co-owner of your company has their own repository, and the main repository is the one at the bank. Still okay so far?
Yes, it is.
Okay. So next term to define here is called a commit. So some action taken that is added to a repository. So that could either be an individual's ledger or the shared one at the bank. So a commit here in business terms might be something like bought 500 units of new inventory for $10,000. So a commit represents a single discrete change in state. Something has changed, you record that change in a repository. Still tracking okay?
Yes.
So this would be like an individual line on a transaction register. So someone has done something, we're gonna update. How does that affect our program? How does that change the state of our ledger? That is what a commit message represents. And commits are discrete, they're separable. Typically, if you are following good code style, your commits will be all organized around one thing. So you try to do something in a commit. You don't want to do a whole bunch of things. You want your commits to be separable so that if you need to roll something back, you're able to get rid of just that commit, undo the changes that are doing one thing specifically. So just keep that in the back of your mind. You don't want your commits to get like basically, you don't want them to be doing multiple things all over the place. You want them focused. And that would be similarly to a business would want each line item in their record of transactions to be for one thing that is easy for them to understand what it is, right? So you buy these items, you sell these items, you make this acquisition, you deposit this amount of money, you get the idea. Yes. Something that is one purpose, discrete, separable, that's what a commit is. And commits are tracked in these repositories. So you commit against a repository. Each person has their own repository, right? Each owner of the business has their record of the things that they're doing for the business, right? So they might spend some money, they might gain some money. Each one of them has a record of these transactions here that we're calling commits. Like, let's say if you have John and Robert and Joe, and all three of those people are owners in a business, they each have their own repositories. Each person would be taking these actions and recording these actions in their own repository. And then eventually, all of these things that they've done would end up at the one in the bank. And so that's what we're going to talk about next. So having made commits against a repository, so they've kept track of the changes that have happened in their local ledger that we're calling a repository. Eventually, we want to have all of these changes recorded in the main one, right? So this is called pushing. So one of the business owners here takes their local repository, so that's their individual business ledger where they've been keeping track of their changes, and they take it to the bank, which is called the remote repository here. So the one that's shared among everyone is called the remote repository, to update the shared ledger with their most recent financial activity. So I think we said John and Robert and Joe, right? Each one of them would take their ledger to the bank, and then they record the changes that they made in the bank's one, right? And then, so after each one of these three people push, the bank's ledger will contain all of the commits from their local repositories. Does that make sense?
Yes, it does. So you can push one commit.
You can, sorry, say that again?
You can push more than one commit.
That is true. Each commit represents one state of change, right? So let's take John, for example. Let's say John bought like, I don't know what kind of business you have. Let's say you're in a grocery store. So John bought a bunch of new fresh produce, and then he sold the produce from the last day. He would have some amount of money going out, some amount of money coming in, and he would record both things, right? But he would record them separately, because if you record them at the same time, what happens if there's a problem with some of the money coming in, right? What happens if someone overcharged or something? See what I'm saying, right? You want to be able to isolate things. So those things would be tracked separately, but then eventually, when all of this is going into the main record for the business, then both of those things will need to be tracked, right? And so when he's going to the bank to fill out what changes he made to the business's account books, he's going to record both things. So both of those things that we're calling commits will end up when he goes to the bank in the final record of things.
Okay.
So that's called pushing. And each one of these commits is basically they have unique names. I won't get into exactly how this works, but you're going to be able to track each line in this will be distinguishable from the others. So you can just think of it as having numbers for now, right? Commits 1, 2, and 3 may come from John. 4, 5, and 6 may come from Robert. 6, 7, or 7, 8, and 9 might come from Joe. And then in the final record of things, you'll be able to see all of those, all 9 of those, and you'll be able to see which one came from which person and things like that. Okay, so a good question then might be, so once people have pushed their local commits to the remote repository, the ones that's shared, then the remote repository has a complete record of all the transactions that happened, of all the commits. Does that make sense?
Yes.
Then the question is, how do the people get that, the complete record of transactions? Well, they want that in their own local ledgers as well, right? Because otherwise they have like an incomplete set of information, right? They're operating on a certain set of assumptions about what assets the company might have, but they don't know that. So John might not know that Robert and Joe spent money on this or earned money here. And so if he doesn't somehow update his local copy to match the shared copy, eventually his state will kind of get out of sync, right? And he'll be making decisions based on data that isn't valid anymore, right? And so just as people can sync the shared copy with their local copies, you can also sync your local copy with the shared copy, right? This is called polling. So you push to the remote repository that contains the shared version, and you pull from the remote repository containing the shared version to get your local version up to date, right? So in our analogy, how this would work is one of the business owners goes to the bank and they go get the shared copy, and then they update their local copy to reflect the overall history of all the financial history across all of the different people. So their local activity is still there in their ledger. They don't overwrite theirs. Their activity is still there, but everyone else's financial activity that they didn't have previously has now been added to it.
Yes.
You tracking?
Yes, I am.
Okay, so this is the general idea of version control. So different people have their own copies of the changes being made, and then eventually all of the changes being made will end up in the shared version that represents like the final state of the project. And that is that shared version is what ends up getting hosted, not locally for you, but somewhere shared. So it's on a server somewhere. GitHub is an example of the bank in our analogy here. They're the people who contain the shared ledger that everyone references. So this repository here on GitHub, this is an example of the bank's ledger, basically, in our analogy. And there's another site called Bitbucket that's the same thing as GitHub. So just as there's different banks, there's different people who will happily support you keeping your ledger that is shared among people on the internet somewhere. Okay, so like I said, this is what I would consider the easier part of the analogy. All of these things kind of directly map onto our analogy very nicely, kind of easy to wrap our head around. I mean, it's just new names for things, for concepts that you can probably already kind of understand, right? And so now things are going to get a little bit more complicated. So the next thing we're going to talk about are called branches. Like I said, things are going to get more complex here. So we've talked now about how there's different kinds of these business ledgers that we're calling repositories, right? There's different ones of these floating around. Some of them belong to individuals. We have the shared one that belongs to the bank. So now, even though we have multiple ledgers, we're going to go a step farther. Now let's say that each ledger is further subdivided into sections. So each one of these ledgers contains one main section that represents the overall financial record. So this is the record of all the transactions that have occurred, kind of by date, so it's chronological and so on. And this is the thing that is kept up to date with the bank's copy, because this represents the total record of all transactions. This represents the overall state of the assets of the company. But you might group other sets of commits, other sets of transactions into a different section. And so the best way to think about this, let me finish here, is that before certain groups of financial transactions, so that is groups of commits, according to our terminology here. So before they go through, and by going through, we mean before they're pulled into the formal record as things that we're kind of saying, yes, these things happened, we're committing these to our history, they're actually going to be tracked separately. And so basically, they're going to be in a different section because they're treated as pending until the transaction's clear. So you might think of these sections that aren't the quote unquote main section. You might think of these sections as representing pending business deals that are almost certainly going to go through. That is, we're planning on doing them, but some additional negotiation on contract specifics might be required before they become final and get pulled into the main record. So very common in businesses, in a business context, someone might want to buy, one company might want to buy another company, but they have to go back and forth a bit to decide on terms and timing and things like that. Or if a manufacturer is buying supplies from a supplier, right? They might agree on a certain volume of shipment and a payment, and they might have dates associated with this or whatever. Well, what happens if in the process of negotiation, something bad comes up, right? They realize that a deadline's not going to be met, the supplier's overcharging them or something. Well, they might want to cancel it, right? And so the problem with directly putting some of these commits that we've talked about, right? These incremental changes, like one commit might be paying a supplier like half of the money up front, and then you might pay them half once the supplies have come, or something like that, right? Or some other agreed upon. You might make some commits before everything is done, right? Well, the problem with making those commits directly to the shared record is what happens if your new business deal falls through for some reason, or if not falls through, you have to like renegotiate. Something comes up, right? Something in this pending set of transactions that you want to do. I'm using a business deal. That's our conceptual unit here for a set of transactions. So not one commit. It could just be a single one, but one or more commits represent this unit of work that we're doing here. Kind of conceptually one thing, but it represents these individual transactions taken to get there. Well, all of these things are going to happen in a separate section than the main section where we're tracking the formal history, because we don't want to have these things end up in the final history of our ledger until we're sure that they're actually going to happen, right? Until everyone has looked at the changes and we've decided that, yes, this is a good thing. We want to keep this. This is what is going to actually be there moving forward.
Yes.
Does that kind of make sense at a high level?
Yes.
Okay, we have a little more to say here. And so like I said, we're calling these things branches. So a branch is a section in an individual ledger. And like I said, by convention, we do have a main branch, the one that represents the overall history. So by convention, the branch representing the overall final record is often called master. So that's the name of this branch is called master, although some people are now calling it main due to some of the unfortunate slavery associations with the word master. So most people really won't bat an eyelash if you call it either one of these things. These are the two names most conventionally used for this particular branch as a concept. And so this is the final record where you're tracking the overall state of like your business ledger at any point in time. And so also by convention, this is what we were just talking about here. No individual co-owner, so no one in the business will have deals that go directly into the permanent record. For the reasons we just said. What happens if something comes up? What happens if something goes wrong? You have to renegotiate terms, something like that. You won't have the records of all these transactions end up in the company records until we're sure that the deal is actually going to go through. So in that way, we will always have a different branch for each new pending business deal in case one of them ends up having issues. And so remember how we were talking about in terms of repositories, each of the co-owners in your business has their own repository, and then there's the shared one. Well, for these pending business deals, the most up-to-date information relating to one of these things, so one of these specific pending deals, right, that set of transactions that's happening in pursuit of some specific goal, well, the most up-to-date information for that will probably be located on the branches. So again, branches are sections in the ledgers of the individual business owners. And so that means that there will be a section in the ledger of a specific individual rather than the shared one dealing with some of the transaction history relating to whatever the pending business deal is. Do you need me to repeat that, or do you think you tracked there?
I think I tracked it.
So again, each individual has their own specific ledger, their own record of the financial transactions. That's called a repository. Each transaction itself, each set of things being done, we call a commit. But in the section of the repository, so in a section of a ledger, you might have multiple commits relating to a new pending business deal. That's the idea of a branch. In terms of relationships, a repository might have multiple branches, and each branch might have multiple commits. Does that make sense?
Okay, just one thing that's confusing me. You said that the branch that represents the overall final record is called the master or the main.
Mm-hmm.
Right? So should I understand that the branch can mean the entire repository, or is there something else I should understand there?
So the repository isn't the master branch. It's not as if the master branch equals the entire repository. So each branch represents, one state of the assets of your company in our analogy. And the master branch happens to be the one that has all of the transaction information across everyone. It happens to be the one that has the most complete state. But a repository actually isn't the master branch. A repository contains multiple branches, right? The repository is the whole ledger, which conceptually contains the main record, but it also contains these other sections relating to kind of pending changes, right? Things that haven't yet come in to the main record, but are kind of in progress. So the repository is a collection of these branches, right? One of the branches, like you said, is the main historical record, has all the changes from the beginning of time related to the financial aspects of your company. But all of these other sections in the repository might be related to these deals that are kind of underway, these things that are still going on. Okay.
I think so. A repository will contain more than just the information on what's going on right now, or what the state of things is right now. It will also contain information about what might yet be, or deals that haven't been.
I mean, I might not think of this so much in terms of temporal sense. I think it's best to think of it as you have a history, right? That's kind of another thing for this log, for this ledger idea. And one history is the one that has kind of been set into stone, right? It's like been recorded in the history books, if you will. That is the master branch, right? This is the one where once things end up there, they don't, canonically at least, they don't change anymore, right?
Yes.
And it's the things that are kind of based on, so if you've ever seen, idea in like time travel books or whatever, how there's like branches in a tree, right? If someone makes a certain decision, then some other things happen, right? But different branches share the same starting point. That is entirely why we use the word branch here, because you might have, let's go back to our people here, John and Robert and Joe, right? So John and Robert, two people who work for the same company, the co-owners of this company, right? So John and Robert might both be working on two things at the same time. Now, let's say that they both start their new business deals right on the date of like March 15th. So that's the day when they look at their ledgers, they go to the bank, they pull, right? So they go to the bank and they update their local history to make sure that they're up to date with what's going on in the bank's ledger, right? So that's called pulling. Now they are up to date. They know that their financial record is current with the financial record for the whole company. So they pull on March 15th and then they start their business deals. And so John's business deal might be different than Robert's business deal, but they both start from the same place, right? So on March 15th, their local ledgers look exactly the same, right? And then they both quote unquote branch off of it because they're doing something new. And so John, let's say he's acquiring trucks, right? He wants to make more logistic shipping for the stores. So John's business deal is relating to acquiring trucks. That's what he's doing. So all of his transactions will be related to, I don't know, maybe buying trucks, retrofitting them, hiring drivers, things like that, right? Well, let's say that Robert, his focus isn't on trucks, but it's on, what's a good thing? I mean, we'll just go with infrastructure. We'll keep on going here. His thing's about buying new store locations. Okay, so John is buying trucks and hiring people to drive the trucks and stuff like that. And then Robert's working on buying store locations, right? And so he might have to buy property, hire a construction company, hire someone to pour the asphalt for a parking lot, things like that, right? So both of them start on March 15th from the same place. They have the same set of financial information. And then John spends some money. He makes some transactions. He has a certain set of things that are branching off from that March 15th point. After he does all of these things, the state of the ledger would be updated, right? And similarly,
Yes.
Robert, starting from March 15th, does another set of things, but starting from that same point, right? And so from a certain point of view, from the perspective of March 15th, if you could look into the future, it's as if a split happened there, right? It's as if those people started at the same place, and then a branch, like I said, think of time travel here. A branch was taken, and if you were in John's shoes, this stuff happened. If you were in Robert's shoes, this stuff happened.
Yes.
Tracking so far?
Yes.
Okay, so that's the idea of branches, right? You have this initial starting state from your history. The master branch, the main branch in your repository represents the shared set of history. This is what's set in stone, the final record. That's where every single new business deal starts from. So every single time you're going to be doing something new, the steps are, first you go to the bank, you make sure that you have up-to-date information on the assets of your company, right? You don't want to go strike out making a new business deal if you don't know what your current assets are, right? You want to make sure you're up to date. And then, so you're going to pull, and then you have your record of transactions. You know exactly what the state of your company's financial assets is. And then you're going to go start doing whatever you need to do for the goal that you have, right? And then you're going to branch. You're going to branch off of the master branch at that time. You're going to have that split where you say, okay, this is the financial information of what we currently have, but now I'm going to go do something different, but I'm going to start with the same thing that is already there, right?
Yes.
Okay, so now this gets more complicated because individuals can have local branches, right? So in their local ledgers, their record books of the finances of the company, so the thing that they carry around with them, they'll have a history of the transactions that they're making for their new business deal, right? That part, easier to understand. However, you can kind of see why the company as a whole might want to track the pending deals going on, right? So both John and Robert are doing things related to company infrastructure, right? Whoever manages all of the finances will want to know how much money is this person spending, how much money is this person spending, what pools, most companies share, they have like budgets. So different departments have different budgets and stuff, right? Where's the money coming from? Can they both use these resources at the same time, or are we going to have problems, right? So you would want to track this sort of thing. And so eventually, both John and Robert are going to want to push. They're going to want to say, you know what, I've been doing some stuff now. I bought my trucks, I bought my property, I've hired some construction workers. I need to go record this information in the bank's ledger so that the other people in the company can see what I'm doing, right? So that they can have a view into the changes that are going to be made if my deal goes through, right? If all of the changes that I've made end up coming into the final record, well, then all of this stuff is going to be affecting other people. And so they have their local copy of branches, right? So this is the section in their personal ledgers of the company finances dealing with their new business deal that they're doing, right? So they have that, but every once in a while, they're going to go back to the bank and they're going to say, here's the progress on my new business deal since the last time I checked in, right? I've made some additional commits. I've done some additional things, right? These atomic operations that represent, changes in the state of the application. I've bought trucks, I've hired people, things like that, right? These transactions are the commits, and you might have multiple commits to a branch, each branch representing this new direction, this new business deal. And then eventually you might register the branches, you might update the bank's record of how your deal's going. And that's called pushing, as we talked about here.
Yes. Yes, okay, I understand it.
Okay, right. So this is definitely more complicated than when we just had this, right? Because suddenly now we're saying that rather than straight up committing to a repository, actually commits belong to branches and branches belong to repositories, right? So each ledger can have multiple sections in it. One section will contain the history since the beginning of time. That's called the master section usually, or the master branch. And then the other ones are these branches representing pending sets of changes, pending business transactions going on. And so a repository is a collection of all the branches, and then each branch has a set of changes associated with it. So the whole change set is per branch, but within that, it will be composed of multiple different commits, multiple different smaller sets of changes representing a very specific change in state. Okay, so definitely more complicated, right? And this is why I said version control can take a little bit to get through. So now we're going to talk about things. This is from the level of organizing your work on a programming team. So we just talked about branches. Now, branches conceptually come about when you have a new goal. So we're going to talk about these things. I'm going to call them work items, although you might hear them called tasks or product backlog items. Depends on which software development infrastructure you're using. So each work item basically represents a block of things you want to do, right? So in the example that we have had here, John's work item was he wanted to increase the number of trucks that the company had for shipping, right? That was what he was trying to do. And so all of the transactions he made, all the commits he made were related to that, right? One commit was buying more trucks. Another commit was retrofitting the trucks. Another commit was hiring drivers, right? All those are separate, but they're all related to this goal of getting more trucks for the company, right? And then Robert's goal was, buying more store locations. So he'd buy the property, he'd hire the construction company to build the store, hire the people to lay out the parking lot. And each one of those commits is separate, but all of those things are working towards the goal of getting more store locations open, right? So each of those commits would be going on separate branches, but actually each branch is organized by one specific like conceptual thing. The branch is trying to do something, right? All of the work for a purpose is towards some end. And that's what we're calling a work item. So each individual pending business deal is typically tracked on its own branch. So like I said, when John is doing his thing with the trucks, he's kind of doing that separately from what Robert's doing with the stores. Each of those things is tracked separately, just as you'd expect in a normal company, right? Because those are kind of separate endeavors. They each have their own costs and schedule pressures and all of the different factors there, but they're kind of done separately in parallel. So each pending business deal is tracked on its own branch so that the pending business deals don't interfere with each other, right? So that everything is kept nice and boxed and all of the work associated with this work item is cleanly separable onto the branch for that work item, right? So if you want to see how are things going on John's acquisition of trucks, you can go see all of the commits that have been pushed to that branch. Again, pushing back here, right? The record of what's gone on in the bank's register. You can go check that for the work item here of acquiring trucks. And you'll be able to see all the progress that's been made on that branch. And similarly, you'll be able to do the same thing with Robert's branch for acquiring store locations, even though it's in a different section of the ledger, right? Those things are being tracked separately, but you can see how both of them have diverged since they split off of the shared history of when the new business deal started. This was the set of assets that the company had and things like that. So as we've said, each one of these goals will be achieved through a collection of one or more commits targeted at the specific business dealing, right? These commits are going to a specific branch, which is tracking all of the changes being made towards this work item, typically with a very definite purpose in mind, right? Again, in our example, definite purpose is John's acquiring trucks and Robert's acquiring new store locations. I give some examples here. In business, the goals might be like acquire X company or sell stockpiled supply to bring market prices down or whatever, right? Each one of these things might ultimately need multiple transactions to coordinate the work being done, but together kind of represent one thing, right? Hence, getting more trucks for the company involves, again, buying the trucks, retrofitting the trucks, hiring the drivers, right? Each one of those is a specific milestone in the process, but together they all compose the idea of getting more trucks, right? And so all of this is why each new business deal is tracked on its own separate branch, right? So that you can track the progress on the work being done kind of separately.
Okay.
Still making sense?
Yes. So all the activities relating to one specific thing that's being done will be on its own branch.
That's correct.
Yes, rather than each of those activities being a branch in itself, they all constitute one branch.
Mm-hmm. Now, the lines can get a little bit fuzzy, like how many things do you clump together? Because arguably, there might be subtasks involved in like hiring drivers too, for example, right? Like you might have to go contract with a labor company and set up health insurance plans for the drivers, and those things are tasks too, right? So do those things get their own branches? Well, you kind of draw a line somewhere and you say, okay, this is the higher level concept that may have subtasks, and those subtasks may have subtasks. And it can break down further than that. But eventually you say everything that goes in this box is related to this thing, right? That is the branch level. Okay. So now we're going to talk about what happens when, despite your best efforts, the branches that you're working on separately, what happens when they come into conflict with each other? And you have to reconcile the records. Let me go ahead and read this. This is going to be one of the harder things to understand here. This process, we're going to call it merging. So in the process of making a business deal, your company's assets and liabilities might change due to the actions of your business's co-owner. So someone other than you, right? Let's say you are in charge of acquisitions for your company and therefore the acquisition budget. Your current business deal might depend on you having a certain amount of capital on hand therein. But what happens if Jeff, who's one of the other co-owners, what happens if he uses some of the company's money in that budget for a really important internal research project? So that money that you were counting on for your business deal, well, someone else just took some of it, right? Suddenly, you now need to reconcile the changes in the global business ledger with your pending business deal. That is your local branch corresponding to one of these work items that we're talking about here, right? So to keep using our example here, let's say that John and Robert were sharing resources, right? They were pulling money from the same place, and Robert uses some of that money to buy a new store location, but suddenly now John doesn't have enough to cover the cost that he thought he was going to have for buying a truck, right? And so how this would play out in a code practice is Robert would go, he would be making his business deals, and then he'd go to the bank and say, okay, here's the stuff I've done. And then similarly, John would go to the bank and be, okay, here's the stuff that I've done, or the things that I promised, the obligations that I have. And then eventually they'd see that, oh, wait, this isn't good, right? Let's say that Robert's stuff finishes first. So Robert closes his business deal. He signs the contract with the people that he's buying the property from. They shake hands. It's in ink, right? Can't be undone now, right? And so he finishes before John. And then John comes back and says, oh, wait, look at that wire transfer, right? Robert transferred more money than I thought he was out of this account. So suddenly John doesn't have quite enough to cover what he thought he was going to have, right? Now he has to renegotiate the terms of his contract. He has to figure out what he's going to do, given the fact that things have changed since he first branched off of the initial history in the ledger, right? So in our example, we said John and Robert were both starting from the state of the company's assets on March 15th. That was what we were using in our example, right?
Yes,
and
yes.
Since March 15th, Robert has pushed his changes, and we'll in fact, he's merged them. We'll talk about pull requests in just a second here, but Robert's stuff has gone into the final record, right? It's now part of the company's business transaction. He's signed it in ink. It's not reversible anymore. And so suddenly now John has to reconcile the fact that the final record has changed. So the state that he started from is not the current state now. So when his changes go into the final record, they have to play nice with everything that's already there, right? And so things have changed since John first started making his new business deal. And so he's going to have to reconcile his contract with the changes that have happened since he first branched off of that initial state. So now he has to reconcile changes in the global business ledger with his pending business deal, right? And that pending business deal is tracked in a section of his personal ledger, right? It's one of the things in his local repository, right? And he occasionally we'll be pushing the stuff that he does to the remote repository, that's to the bank's ledger, saying, okay, here's the progress I'm making in my business deal, in this set of tasks that I'm undertaking here. Okay, so a lot of the time, you won't have to scrap your pending deal entirely, right? But you might need to figure out how to square what new thing you were trying to accomplish with the changes in the company's overall ledger, right? So if someone else touches something that you were depending on or relying on, you might have to make some tweaks, some changes to adjust here. So this process of reconciling what has now become the final ledger, of reconciling the changes in the final ledger with your branch is called merging. So it usually involves combining your new pending branch, so this section in your local ledger, with the master branch. So occasionally you might actually merge two branches where one of the branches isn't master, right? So if you have two business deals going on at the same time and they're kind of related to each other, you might say, you know what, we should be tracking all of this stuff in one place, right? And you might consolidate branches actually. And in that case, you would merge one branch into another branch. And you'd say, okay, like let's say that John, who's acquiring the trucks, let's say that he has a subordinate named Jim. Okay. And so Jim was working with some other thing. And initially the company was tracking their stuff separately, but then they said, you know what, Jim's stuff is really kind of under John, right? Jim's negotiating the labor contracts or something, but his stuff really part of John's goal, right? Relating to all the trucks. So then they might merge those two branches and track all of those changes in the same place. Does that make sense?
Yes.
So normally, the most normal thing that you have to do is you have to merge the master branch that has changed because someone else has done something since you branched off it. Since you started your new project and you've been making changes to the record as your company had it from that point in time. Well, now suddenly the company record, the global company record has changed. Now you have to reconcile the changes that you've been making with the changes that someone else made, right? Usually that is what you have to do when you merge, right? You have to reconcile the two records to make everything work and play nice with each other. So it's actually pretty common to have merging be easy. So this might sound scary, like anytime someone else changes something, everything's going to break. That's actually not the case. A lot of the time, you don't have to do anything. So in our example that we brought up here, where Jeff kind of pirates some of your acquisition budget for his internal research project, right? Well, if Jeff were, rather than taking your money, if he were to take money from the R&D budget, let's say your company has an R&D budget, well, it wouldn't actually mess with the acquisition budget that's important for your new deal. And therefore, it wouldn't like mess with your new deal, right? And so your new deal could still go through, even though Jeff did this, and even though the company's spending money over here now, well, you don't really care because it doesn't really affect your stuff, right? And so you'd still want to know about Jeff's expenditure, right? So you'd still want to go to the bank, as you do periodically, to go to the bank to pull, right, and get that updated ledger for the transactions of what everyone else has done. And so you'll go there and you'll be like, hey, any changes? And they'll say, oh yeah, look, Jeff bought this stuff for that internal research project. And you'll be, okay, cool. I'm glad that progress is being made over there, but that's not really my stuff. So, I'm happy to see my acquisition budget still untouched, right? All that money I need for my business deal, well, I still have that, right? This is actually probably the more common case, especially if your team is well coordinated. So if you have good meetings at your company, you try not to have people step on each other's toes, right? You try to make sure that people are working on independent things, that they're not going to cross each other's paths and get in each other's way, right? But sometimes it happens, even if you don't intend for it to, sometimes it happens anyway, right? But a lot of the time you can get merging doesn't always have to be gross. So we still call it merging, right? We still call it merging. So taking what's in the master record and putting it in your own record so that your own record is up to date with the master one. We still call that merging, even if there aren't any conflicts. It's still merging. We just call it an easy merge, right?
Okay.
And so if you think of this again as that decision tree where we have branches. So this is why they use these words, right? It's supposed to help us envision this idea of history. So if a branch is where something deviates from like this common path, right? Well, when you merge, you're going back into the common path, right? So you're coming off it, and then you reconcile your changes with whatever's there, and then you go back into it, you merge back into it, right? That's how you ought to think about this, right?
Yes.
Now, so we said sometimes, and in fact, a lot of the time, if you organize your work well, merging won't be that bad, right? It should happen completely automatically. You don't have to worry about it because no one will be touching your stuff. But if there are conflicts, suddenly then you have to reconcile the two records that now conflict in some area. And this can sometimes get really, really messy and gross. This is a very challenging part of being a software developer. Usually all it takes is a time or two for you to have a really gross merge for you to like get it through your head. This is terrible. I never want to do this again. And then you'll be sure to communicate better with your teammates so that it doesn't happen again. You'll get the hang of this. Communication, very important in avoiding really bad merge conflicts, right? So in code terms, I'm gonna break our analogy for a second here. In code terms, if you and a coworker are both working on the same file, changing the same functions, you're gonna step on each other's toes, right? You might change the same line of code. And how is the ledger, how is the record here, how is it supposed to know which change it wants, right? It can't do that on its own. That's how you have to resolve conflicts in code. Now, for our business transaction, this might be someone's using money over here, but you said you were using that money. Who actually gets to use the money, right? That's in our business context, the idea of these conflicts here. So again, merging, sometimes it's easy, but if it's gross, it can be really, really gross. And so let me again emphasize that an ounce of prevention is worth a pound of cure here. So it's definitely advisable to tell your co-owners to temporarily keep their hands off of your acquisition budget if you know that you're going to be dealing with it. So in code terms, if you say, hey, I'm dealing with this function and this file, don't touch it. Sometimes it'll be harder because sometimes everything's connected and it's really hard to avoid stepping on each other's toes, but as best you can, good communication can help you avoid really gross merge conflicts. It kind of depends how big your team is too. All right, so last thing to cover for merging here is this idea of merge conflicts. So merge conflicts are the things that cause the merge to not go easy, right? The specific areas leading to some form of conflict when merging two branches. So merge conflicts arise when these two different ledgers are trying to do something different with the same resources. So in our example on this slide, this would be with the acquisition budget, right? And if you're the only one using it, you won't have any problems. But if someone else suddenly starts using it too, then you have to know, well, who actually gets to use it and what do they get to do with it? Because if you have two different reports of what is happening with it, then how is the bank record, the bank ledger, which represents the final set in stone state, well, what goes in the record for all time? And that will need to be reconciled.
Okay.
Okay, how are we doing? Think you've got everything still so far?
Yes. Yes.
Okay. So next we're going to talk about pull requests. Okay, so now we've talked about repositories, commits, pushing, pulling, branches, work items, which are the things that kind of represent the work that happens on a branch, and then merging, which is when you get one branch stuck into another branch so that you can get that final record ironed out. Now we're going to talk about pull requests. So once a business deal, and that's what we're calling a work item or a task, has been completed and all contract negotiations have been finalized and looked over, which means that whoever's been running point on this business deal has pushed, they've put their changes in the bank's ledger, not in the master branch, not in the main section of the bank's ledger, but in their little section detailing all the work that they've been doing on this business deal. So they've put it in a place where everyone else can see it, right, in the bank's ledger. So in that part of the bank's repository, they push their branch to the main repository so that other people can look at their branch, right? So once the person has done that and the business deal has been inked into the bank's version of the ledger so that some or all people in your company have been able to give it a look and approve it. So after that happens, a request is made to incorporate the new deal into the main section of the bank's official ledger. So this is the step in which it becomes written in stone, right? It gets added to the main history that shall not be touched. Branches, branches branch off the main branch, and to get merged back into the main branch, the actual thing that gets them stuck back into the main history is called a pull request. So a pull request is really kind of like a special kind of merging, right? So you merge, you typically merge master into your local branch, and then you open a pull request to get your local branch stuck back in master. So this is after your new business deal has closed. You've made all the transactions you need to do to get something done. Everyone has approved it. So this is an important step. It's called peer review. So you peer review pull requests. You say, hey, I think I'm done with my business deal. Here's all the things I did. Does all this look right? Does it check out with the goals that we had in mind for this? And then you'll get other people from your company to come and look at it, and they'll be like, yeah, that looks like what we wanted. Go ahead and put that in our final history, right? That's what pull requests are. So typically, and again, note the emphasis here, pull requests are typically always against the master branch in the bank's copy of the ledger. So each individual person will have a local copy of the full history, right? So they'll have a local copy of the master branch, but you don't put a pull request against that. What you put a pull request against is the bank's version of the set in stone history, right? Because that's the thing that represents actually the current state of your project. If you remember, when we were setting up our analogy, we said that the real copy, so to speak, is the bank's copy for the main branch, right? So if you get audited by the IRS, that's the one that's important, right? And so what the pull request does is it says all of this work that we've been doing in an area, now that's going to go into the IRS copy of this, right? That's going to go into the main important one that is shared between all people.
Okay. So a pull request is different from a pull.
That is correct. So a pull is something that an individual does where they go to the bank and they get a copy of the bank's main ledger, right? That's what pulling is. Actually, you don't just get a copy of the main ledger. You can actually get copies of other people's business deal branches, right? So you can pull down any branch. As long as the branch has been entered in the bank's ledger, you can get a copy of that section of the ledger. Does that make sense? So, yes. So in our example of John and Robert earlier, John's doing the truck stuff, Robert's doing the store location stuff. As long as both John and Robert regularly go to the bank and update the bank's ledger on their progress, the other person will be able to keep an eye on what the other one's doing, right? Because they'll be able to go to the bank and they'll be able to pull the other person's branch and say, okay, good, he's done this and this and this, and they'll be able to watch each other's progress, right? So you pull branches from the bank. A pull request, I know this, people don't like the word. I hate how they named this. This is how it's been named. We can't change it. But a pull request is kind of like the opposite of pulling, because pulling is the bank's ledger. Basically, you're getting a copy of the bank's ledger and it's putting it in your own ledger. A pull request is, you're opening a request. Other people have to approve it, right? They have to look it over and say, yes, we want this, but it's going the other direction. It's saying, hey, I made some changes in my local ledger. I've now pushed those changes to the bank's ledger, but now I want this section of the ledger, I want it to become one with the main section. I want to merge it into the main section. So you're taking, whereas pulling normally is you getting something from the remote repository, right? A pull request is you take something from your local repository, you push it up to the remote repository so it's in the shared ledger, and then you're going to combine that with the master branch. It's kind of like, it's not exactly the opposite, but it's definitely different, right?
Okay.
Okay. So, I mean, I know all of this is very hypothetical. It's all very abstract right now, right? But hopefully the analogy is helping kind of us orient ourselves in terms of what these things mean at a high level. All right. So even as much as we've gone through here, right, believe it or not, we've actually made quite a few simplifications for how this stuff actually really works. So I give two examples here. It's not an exhaustive list. There's other points to be made too. But in a real production environment, so this is like when you're deploying to an actual server, you have an application that a whole bunch of people are hitting. There's actually usually several branches that correspond to some finalish version of the ledger, right? So in our previous discussion, we've been saying that the one history version is called master, right? That's according to the discussion we previously had. It's actually a little bit of a simplification. A lot of the times, you'll have multiple versions of this so-called final state, right? So all of these different ones might have pull requests against them rather than just having a single master branch. So it's actually common to have no branch called master, and instead you'd have three. You might have a branch called dev, a branch called test, and a branch called production, which everyone just calls prod. So the split here, this is the one that you and your team push to when you're like developing a new feature. Test is when the feature goes to whatever testers your customer has to make sure that you're doing the right thing. And then production is when it goes into effect for like final end users, right? Now, some people might have four. Dev, same deal, right? This is where you and your team are working on stuff. It's kind of in progress still. Integration, this is an extra step where suddenly you're pushing to your deployed environment. This is still not, it is not crossing the eyes of external testers. It's still you and your team. But what you're doing is if you're pushing your code onto a server rather than running it on your own computer, you need to make sure that that environment works well. So both of these are pretty common development patterns. So each one of these three things kind of represents a final state, right? So generally speaking, dev has more recent activity to it than test, and test has more recent activity than prod. And so in terms of like what's most up to date, dev will be most up to date, but it's also less stable, right? Because you might have stuff that ended up in dev, but maybe there's a bug or something. So these are actually pretty common, like quote unquote real approaches, right? For small projects, a lot of small projects actually really do just have master, right? And they do make pull requests directly to master. If you don't deploy somewhere else, maybe you don't need as much of this other stuff. So actually my projects, it's actually getting kind of late today. I don't know if we'll actually look at the code side of this today, but my project here, you see, I only have one branch and my branch is called master. So smaller projects that aren't deployed as much, it works fine with just one branch. But so that's, one level of complexity that we're going to kind of wave our hand at right now and just not worry about so much. So even when you're on a team like this, usually you'll have some of the production guys, particularly more senior developers who have been in an environment like this longer, who know more. They'll be the ones who probably handle the deployments to test and prod. And so especially as a normal developer, a junior dev, you'll probably still mostly be interfacing with just one ledger at the bank in our analogy. Just rather than calling it master, you're just going to call it dev instead. That is probably the version control source that most people are going to be familiar with as software engineers. Most of the time, the work that you do will be pushed to a branch called dev. That's normal. So for now, just think of things like this, right? Dev will be the name of the shared ledger that the bank has. I just want to introduce this to you to make it clear that we're making some simplifying assumptions here, right? And so don't get super wedded to exactly how I'm describing it, because if you ever go into a real job, it might be set up a little bit differently, but the concepts are what's important, right? So the other thing is, thus far, we've been saying that history that we've been talking about, we've been saying it's set in stone. After something goes into the final ledger, it shall not be undone, right? Well, actually, you can muck around with the history. So sometimes people rewrite history and change the record of what happened in the ledgers everywhere. So obviously, this can cause lots of issues, right? Because what happens if John doesn't go to the bank for a week? Well, suddenly, if the bank has like rewritten their ledger, John's operating on something that's like really wrong, right? So what happens if someone goes forward with an out-of-date ledger? You have all sorts of issues. So what we're talking about here is called rebasing. So you basically rewrite history in the ledgers. So things that you said happened, they say they didn't happen or they happened differently, right? So usually this is avoided if at all possible because it causes a lot of issues. Sometimes it needs to happen anyway because life. Sometimes bad decisions are made. Something gets in your code base that shouldn't be there. Like a common thing for this is if someone actually ends up committing a password, like a password in one of your code files. Right. So you have a connection string to a database, for example, and you need to be authenticating on that database, and someone pushes the actual password into version control. Well, guess what? That's a huge security flaw, right? You can't have a password in your code. That's not okay. However, in version control by default, even if you put another commit to remove that password, guess what? It's still visible in version control, right? What you want to do is make it so that as if that password was never there, right? And to do that, the only thing that you can do is to rewrite history. The problem is as soon as you rewrite history, anyone who had a branch open at the time where you rewrite history, like they're completely screwed because suddenly what they branched off of no longer exists, even close. It's not even remotely the same, right? And so this causes lots of issues. Again, you as a junior developer probably won't worry. I mean, so by the way, upshot of this conversation, don't commit passwords to version control. Terrible idea. You will get in lots of trouble. But that aside, you probably won't be the one doing this, right?
Yes.
If you need to ask, hey, senior developer, how do I rebase? You should say, here, you do this. Also, do we really need to do this? You should ask that question too. Rebasing, very frowned upon. Sometimes it is necessary though. Like I said, excellent example. Someone gets a password in version control. You need to wipe it out as if it had never been there. The only way to do that is to rewrite all the history. But as a general practice, this doesn't happen. It's happened once on my project here. And I'm trying to remember why we did it. Something got super, super messed up. Someone pushed, they merged a branch into our master branch. This was before we'd split into like a dev and prod branch. And they pushed something into our main branch that just like broke everything. And we couldn't figure out where exactly it went wrong. And we wanted to just get rid of that thing that had gone in and say, you know what? Somehow this got through peer review, but it broke everything. And we don't know where it broke. And we can't just like not have our app functioning for like 2 weeks while we try to figure it out, right? And the problem was things had gone in since then, right? So this thing went in and then something else went in on top of it. So we needed to remove that as if it had never been there. So I think it's only happened once on my application, and I've been on it for about 2 years now. So in production environments, quite rare. And you want to avoid this if at all possible. But okay, enough on that. These are the exceptions, right? So just take my word for it. There's some nuance here that we're not going into just because it's not super helpful the very first time you go over these things. But, don't be shocked if in the real world at some point, something comes up a little bit different than the main process that we're going over. But we're going to focus on that main process because it's the general development workflow that you'll see as a developer. So I know we've just been dumping lots of data on you right now. We have just a little bit more to get through. And then I think we're actually going to call it a day there. I would encourage you to go back and try to make sure that all of the stuff that we're talking about makes sense in your head, because we're going to go look at what all this means in terms of code next time, right? We've been talking conceptually here, but all of the things, I think I picked my analogy pretty well. I think everything should transfer over pretty seamlessly. So if you understand how everything works here, then I think you should understand how it works when you're version controlling a set of text files code-wise. So just some other terms that you're going to need to know. So cloning is the very first time that you as an individual stop by the bank to get a local copy of the ledger. That's called cloning the repository. So maybe your company hires a new person who's going to be in charge of something. Well, they don't have all of the company's assets up until now, right? So they need to go get a copy of it. So they go to the bank and they say, hey, Mr. Bank Teller, I'm new to the company, but I need a copy of this information. And say, okay, here you go, right? That's called cloning the repository. You get a copy of what the bank's copy is, okay?
Yes.
So cloning is something that individuals do. So from the remote repository, you clone the remote repository into a local one, something that the individuals do. So simple enough, right? That's actually not one of the hard terms here. Something else that might happen in this is you might want to ignore certain things from version control. So here's the analogy I use in our business analogy. So let's say that your company has an internal fund for helping out employees or their spouses with medical costs from cancer, right? So I work for the government, right? I work for the Air Force. We actually don't have something directly like this, but what we do have is we have what's called a voluntary leave transfer program. So if people have a spouse with a severe medical emergency like cancer, or they're out of work due to debilitating health condition, if you want to, you can donate your annual leave to them, right? If someone has to be out for circumstances that it's out of their control, it's hard, and they don't have enough vacation for it, you can say, here, have some of my vacation. So I actually have something kind of similar to this in my job, right? It's elective. So employees at your company, but for our example, let's say that it's actually monetary, right? So your company has an internal fund for helping out costs related to cancer for employees and their spouses. So employees at your company can voluntarily elect to donate to this internal fund. However, as a business, you don't really want to track this as like business assets, right? Because this isn't material to your business applications. This isn't relevant to like your bottom line or the amount of capital you have for acquiring equipment or means of production or logistics or whatever. Like you can't use this, right? This is just internal to your company, right? So this is something that you really wouldn't want to be tracked as part of your business's overall assets. Do you see why? Right? Like this isn't really relevant to the overall scope of your business. And so for that reason, you would specify that you want this thing specifically to be ignored in all the ledgers floating around everywhere. So this is every ledger in existence, right? So this is John's ledger and Robert's ledger and Joe's ledger and the ledger at the bank. And if you have multiple ledgers, like we said here with like dev, test, and prod, right? All the ledgers, everything, you're going to be ignoring this stuff, right? So code-wise, this is what is called in code. It's a file called a .gitignore, right? So it's a hidden file called .gitignore. This is basically just a list of stuff that you want to ignore. So you want to say, I don't want this thing in version control. And so whenever you come across this and it gets confusing in your head, think, I want to ignore this from version control, just like how a company would want to ignore their internal cancer fund because it doesn't relate to their operating expenses, right? They don't want to track it in their main assets ledger. Same thing in our code base. There's some stuff, well, we don't care about, right? So something that's common for this, different people might have preferences according to their text editors. And oftentimes those things, you remember, we've actually seen this. We've seen this in our examples already. So this .vs code folder, right? So right now we just have a launch configuration, which you probably actually want to share across people, but you might have like a settings file here that contains like my key bindings or something for VS Code. I don't really want to commit that to the shared repository because it's not going to be relevant for other people. It might just get in the way, right?
Yes.
That's the sort of thing that you'd ignore. Okay, so that's ignoring files. You specify the files to ignore in this thing called a gitignore file. Very analogous to how companies might not track everything on their balance sheets, but only the stuff that's actually relevant for their company. Good so far?
Yes.
Okay, just a couple more things. So we have this idea of staging changes, unstaged changes and stage changes. So if you have work on a branch that you're doing that has been completed, but you haven't committed it yet, right? So it can be in one of two states. You can either have it unstaged, and that means that if you commit, the next time you commit, and so you say, I've made this set of changes. So it means that if it's unstaged, it won't show up in your commit. So your next commit, you pick a set of stuff that you want to say, hey, I did this stuff. And that's your block. This is the stuff I've done this time, right? But if you stage it, it means that it will be part of the next commit. And so it's actually quite common. If you task out your work well, it's pretty common for you to stage all of your current changes when you commit something. So basically everything you've done since the last time you committed, you'll stick in the next commit, right? But sometimes you might get a little bit ahead of yourself and you'll implement one thing and then you'll implement something else that's really not that related to it, right? But you'll do it before you committed the last stuff. See what I'm saying? And so sometimes after making a set of changes, you might want to have two or more separate commits to better organize the work that you did into discrete chunks. And so let me give an example here, right? Let's say that you had someone who worked for both John and Robert in our example, right? Let's say that this person's specialty was like hiring employees. They were an HR person, right? And so the HR person might have done stuff on John's project relating to hiring truck drivers. And he might have done stuff on Robert's project relating to hiring like construction foremen or supervisors or whatever, right? And so he has hours billed to both of these things, right? So he might have done work since the last time he went to the bank and reported the stuff that he did and how it affects the company's ledger, right? He might have done work on acquiring trucks and acquiring new buildings, right? But since the last time he went, he hasn't kept in his record. He didn't put those transactions as, you know, did truck stuff or did banks or did a building stuff, right? So he has all of these things that he has ready to record now, kind of all jumbled up, right? In this circumstance, it'd be better for him to not put all of that stuff in one commit. It would be better for him to break it up and say, okay, here's when I did truck stuff and here's when I did building stuff. See what I'm saying?
Yes.
Okay, this is very, 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 very indicative of programming experience. A lot of the times new developers, just because they're not used to it, will have commits that just contain a whole jumbled mess of stuff. They don't organize it very well. because they're just saying, I did all the things, it works. I don't want to care about organization or structure, whatever. I'm like, here's all the changes I did, and you'll have these big change sets. I mean, even those of us who've been at this a while, sometimes we get lazy, right? Or you fix something and you just, I don't want to go dig through line by line and figure out what should go where. But the benefit of having more atomic commits that are very focused on one specific thing is if something breaks, it's much easier to roll back a small set of changes than it is to roll back, a huge set of changes, right? Because it makes it easier to pinpoint what you need to undo to fix things. This is the idea of staging. So unstaged changes, and here, let me show you an example. I know we won't get into a lot of code stuff today, but this is the example. So you see here, it says unstaged files right now. So down at the bottom of the screen, this is where I can type my commit message. So I could say, did this work, right? And so right now, if I commit here, I don't have any changes in my change set. I don't have anything that I say I've done in this commit yet. But you see here, I'm deleting right here. These are 2 temporary pages that I had scaffolded when I was testing stuff, right? So both of these things, I'm deleting stuff. So you can see it's all red in the change set here, right? But I could paste a commit here. And if I wanted to call this something specific, I might call this like delete no longer needed scaffolding, right? So if I make that my commit message, it's actually very clear what I'm doing, right? What's this commit doing? It is getting rid of no longer needed scaffolding files, right? But let's say that I update this path bit in the general Python folder, right? This was me last night. I was trying to get my slides parser to work on stuff in the root directory, right? So now if I add this file to my change set and I say delete no longer needed scaffolding files, well, is this right? Is this right here deleting no longer needed scaffolding files? Like, no, has nothing related to that at all, right? And so if I later come back and I'm trying to find, there's a bug related to the general program loop, right? Where'd that get introduced? I'm not gonna be able to find it if I put it in this commit that has stuff that's not related to it, right? So in this regard, what I'd want to do is first I'd want to commit these things. Over here, I'd want to commit the deleting the no longer needed file. I'm not actually going to do it because I need to go like organize all this stuff. But after that, after I got those deletions up, then I would come to this and I would say, like increase files first for slides or something like that, right? I'm doing a different thing here. I would want those things to be split out and separate because that's better organization. Does that make sense?
Yes.
So you get to pick here. This is the interface for source tree. One of the reasons why I like source tree is really easy to see what changes are involved in your change set because you can go ahead and just look, like you can preview the changes here, like you see, right? It makes it easy to see like what you are and are not getting ready to put in an actual commit. Okay, last main thing then for today, we're going to talk about diffs. So diffs, quite simply, you see this thing over here? This is a diff. It shows you the changes. It shows you red stuff. Red stuff is deletions. Green stuff is additions. That's it. That's what a diff is. So, I mean, I have some more words here. I say comparisons between 2 different versions of the company ledger to highlight where the differences are. By convention, things highlighted red are deletions, things highlighted green are additions. See, this is actually me talking about some of the actions of the patriarchs, it looks like, right? What's the actual context? Whatever. But, like you see, red are additions. I'm not done with this yet. I'm still editing this particular piece of content. But, red are deletions, green are additions. And, oh, no, actually, no, this isn't that. This is the slides. This should look familiar. This is the slides that we did when we were looking at role models, right? So Moses, Job, Joseph. So I haven't committed that to version control yet, but that is what the diff is. It shows you the differences in the files that you're working with. And so we might commit this, right? We might, which one is this? This one? Whichever one it is, right? We might commit that and put those changes in the bank's ledger, so the shared version of things. But diffs are very important for you to get used to looking at, because this is how, when you're reviewing someone else's code, you want to be seeing what stuff they changed. And so you'll be evaluating the things they did. I mean, you want to functionally test it too, make sure that the stuff does what they say it does, but you'll also be looking at the code. And most of the time, you'll just be getting a chain set. You'll be getting one of these diffs. The difference between the master branch and then the branch that you're putting up for pull request to put into the master branch. You want to see the differences between them to make sure that everything checks out, that everything looks okay. All right, so we've skipped some other stuff. And I mentioned that peer reviews happen when pull requests get put up, right? So other people look over your code, they approve it before it gets pulled into master or dev or test or prod or whatever. So peer reviews are a part of the pull request process. I'm sure I missed some other stuff, right? I came up with all of this afternoon. So, entirely possible that I missed other things, but I think I got most of the big stuff here. And so, initially I was intending us to actually look at some code today too. I don't think we're gonna have time. So we'll pick up with this next time, probably specific examples in a Git repository. So, we'll look, this is a pull request from this branch about the site content section into the master branch. And you can see that this pull request on this branch here, this branch has lots of commits to it, right? So we'll look at this next time once we have some time to actually look at the code version of this. But hopefully the analogy has proved helpful here for getting our feet wet conceptually into the idea of version control. So just closing us out here. Actually, do you have any questions before I jump into summarizing everything we've talked about?
So far I follow. I'm not confused by anything so far.
Now the trick will actually come when I say, okay, great. Now you make a branch and you make a pull request, right?
Yes.
Right. Yeah. Then it always becomes challenging when you're the one who has to do it without someone holding your hand, right? But okay, well, I'm glad that was hopefully clear. So that's what we did today, right? We talked about how this stuff can be tricky to understand, especially for the first little bit, right? Once it clicks and once you have all these things straight in your head, you won't have such a hard time of it, but it can take a little bit for things to click there. So then we talked about our analogy here of viewing this idea in terms of like transaction ledgers for businesses. So the business accounting, a good way, kind of parallel analogy to use here to tracking code changes and version control. So we talked about repositories, commits, pushing and pulling, right? So repositories being the local copies of the ledgers that individuals have versus the one at the bank. Commits are these kind of atomic operations that we're doing, these transactions that get recorded in the ledgers. Pushing is when someone takes their ledger and updates the bank's ledger based on what they've been doing. Pulling is they go to the bank, they get information about what other people are doing and put it in their own ledger, right? We talked about branches and work items or tasks, right? So each work item or task has its own branch that you do work on, kind of analogous to pending business deals, right? So all the stuff related to acquiring trucks goes on one branch, all the stuff relevant to buying new buildings go on another branch. So the two branches can be worked in parallel without getting in each other's way, right? And we talked about merging. So that is reconciling differences in the history since you last branched off of something, right? If someone else has stuff that goes into the main record, and then you're going to have to reconcile that with the changes you've made as well. And sometimes this doesn't require too much work on your part, right? If their changes were in something that you weren't working on, but sometimes if you do have conflicts, it can get kind of messy to resolve those. Then we talked about how after this, once you think all of your stuff in a pending business transaction is done, you might put that up for pull request to kind of put it in the history that gets set in stone, right? So the official record of your application's history. So to do that, you open a pull request. You'll have some coworkers or teammates peer review the pull request, look things over, say, you know what, this looks right. This does what we want it to do. We've allocated all of our resources accordingly. I'm going to go ahead and approve this, give it a green check. And then once you get however many approvers you need, that will go and it will be set in stone as final history. We talked a little bit here, I'm not spending too much time, but just about how we're making some simplifying assumptions just for the sake of making this easier to understand the first time. But don't be surprised if you have multiple branches like dev, test, and prod when you go into a real application development environment. And sometimes, even though we've been saying that this history is set in stone and doesn't get changed, well, if someone commits a password to version control, it will get changed. There are some circumstances where history does need to be rewritten, but you try to avoid it if at all possible. And then finally, we talked about some of these other terms, cloning, right? So getting that ledger the first time from the bank, ignoring files in our business analogy, just like how a company would ignore the assets relating to an internal fund for helping employees with medical expenses, unstaged changes. So the idea that you want to have very organized commit messages so that when you are kind of recording the transactions that you did inside your ledger, so that people in the future will have a record of what was done. You want to break things up into these atomic operations, these things that are descriptive of one thing and one thing only, so that it's much clearer and easier to roll back if you need to. And finally, we talked about diffs, which are the red and the green everywhere that, oops, let's not do that. The red and the green everywhere that represents what you added and what you removed. So I think that's where we'll stop. Quite a whirlwind introduction, lots of information today. So I would 100% recommend once I post this video that you go back and you look at it if you need to. Just make sure that you have all the differences between these things clear in your head, because we will pick up looking at this in terms of code the next time we meet. So with that, that's where we'll cut for today. And we'll talk to everyone again when we pick up next time.